Greetings to everyone, we are from Group 8 and we would like to present to you guys about the reversible process. This are the group members, Jafrin, Afik, Ayu and Thivia. First and foremost, we all must know what is the reversible process history of development. It was believed that all chemical reactions were irreversible until 1803, when French chemist Claude-Louis Berthollet introduced the concept of reversible reactions. Initially, he observed that sodium carbonate and calcium chloride react to yield calcium carbonate and sodium chloride. However, after observing sodium carbonate formation around the edges of salt lakes, he realized that large amount of salts in the evaporating water reacted with calcium carbonate to form sodium carbonate, indicating that the reverse reaction was occurring. Next, what is the definition? A thermodynamic process is said to be reversible if the process can be turned back to such that both the system and the surroundings return to their original states, with no other change anywhere else in the universe. There are two types of reversible process. First is internally reversible process. The process is said to be internally reversible if no irreversibilities occur within the boundaries of the system. In these processes, a system undergoes a series of equilibrium states, and when the process reverses, the system passes through the same equilibrium states while returning to its initial state. The second one is externally reversible process. In an externally reversible process, no irreversibilities occur outside the system boundaries during the process. For example, if the surface of contact between the system and reservoir is at the same temperature, then heat transfer between a reservoir and a system is an externally reversible process. These are the examples of reversible process: frictionless relative motion, isothermal expansion or compression, expansion and compression of spring, polytropic expansion or compression of a gas, electrolysis. Next we will see pressure-volume graph. These are the process that consist in pressure, volume graph, which is isothermal process, isobaric process, isochoric process and adiabatic process. Let's try the example question. 1.00 moles of an ideal gas, Cv equals 3/2 R, initially occupies 22.4 L at 273 K. The gas expands adiabatically and reversibly to a final volume of 44.8 L. Calculate delta T, Q, W, delta U and delta for the expansion. We can solve this question using MATLAB. First, list down all the important information from the question and insert them in MATLAB. As the ideal gas undergoes adiabatic expansion, this Q equals to 0. So Cv can be calculated using the formula given in the question and the used to calculate T2. After getting the T2 value, we can calculate delta T. The final answer for delta T is minus 101.02 Kelvin, showing that the temperature drops at the final state. Then by using equation W equals NCV delta T, we will get W, which is work done by the system. Since Q equals 0, delta U equals W equals, based on the equation, we can obtain the value of delta H. The references that we use. That's all from us, thank you.